In this video, we'll be talking about the quotient rule. This is one of the harder rules, but it basically has you find the derivative of some functions in fractional form. So if you have some function f over gx, then you must follow this format to find the derivative. And this could also apply if you had f divided by gx. So the format you need to follow, how my teacher taught me to at least, is low, so the lower portion, d high, so derivative of high, minus high, d low, over low, low. So the function of g squared. So remember that. Low, so the lower, the denominator, d high, d, the derivative of the higher part of the fraction, minus high, d low, over low, low. So low times low, which is just denominator times denominator. So low d high minus high d low equals low, low. And then, over low, low, sorry. Low d high minus high d low over low, low. And that's your quotient rule. Now, either you use like some song or Buck Beaver stuff, I don't even know. You have to memorize this. Likely won't get a formula sheet for this, unfortunately, but you likely have to remember this. And this one it's quite tedious to solve for the quotient rule's derivatives. But let's go ahead and do some example problems to show you how to use this. So let's go ahead and find the derivative of this function. The derivative of this function must use quotient rule. So let's go ahead and use quotient rule here. And keep in mind the order in which you put these at the top matter. You must do the minus f times g prime. You can't put fg prime minus gf prime. You cannot switch these places. So the order matters when you're doing quotient rule. So let's go ahead and label what we have. This is f of x and this is g of x. Okay? So g, so low, x minus 2, d high, the derivative of the higher portion, or the derivative of f, which is 2x here, using power rule, minus high, x squared, plus 1, d low, which is the derivative of the lower portion, but the derivative of this is just 1, over low, low, which is x minus 2 squared. So the derivative of this function is simply this entire thing. And if you want to simplify this further, usually you wouldn't need to simplify it. Your teacher would likely take an expand answer like this, since you're not taking algebra class. But if your teacher asks for you, you just need to do a little bit of algebra, and then this thing works out. So you get x squared minus 4x. Since this coefficient cancels out with a minus x squared, minus 1 over x minus 2 squared. So this is your derivative. So this is your derivative of your function right here. So really all you need to do is just memorize this and then follow the format. Let's go ahead and find the derivative of this. So the derivative of this is low, so x squared, d high, the derivative of sine is cosine, minus high, sine of x, d low, over low, low. But x squared is also x to the power of 4, so we can write down x to the power of 4 instead. And you really don't need to rewrite this. This has no way of simplifying, so all you need to do is just, well, I guess you can factor out an x. I guess I'll do that for the sake of the video. So you have x squared cosine x minus 2x sine of x over x to the power of 4. And then you can cancel out the x's here. So this turns into x to the power of 3. So if I rewrite this, I should get x cosine of x minus 2 sine of x over x to the power of 3. And this is equal to our derivative, dy over dx. So again, just memorize and follow the rules. Alright, Now, keep in mind, when you're using these derivative rules, you still need to use product rule when you're finding the derivatives of, let's say, your function even. So what do I mean by that? You still need to use the proper rules for deriving things. So let's say this is f and let's say this is g. All right, we start off with low, so sine of x plus 1 d high. So this is where this gets interesting. The derivative of the higher function is comprised of two functions. So we need to use product rule here. So what's product rule? Product rule is the derivative of f times g is equal to f prime g plus f g prime. Okay, so we need to follow product rule here. All right, we don't just skip that part. You can have quotient rules in quotient rules as well, which is hopefully you don't get that, but this is a product rule in a quotient rule example. Let's use different letters. Let's use a and b for this. So a, actually let's just use f and g. I wrote the formula in f and g, so let's just use f and g. F g. And then we use product rules for these two fg's. We can change the color of it to make it more clear. So so the derivative of f is 2x times g, which is just cosine of x, plus f, which is x squared, plus a derivative of cosine, which is negative sine. So I need to erase this plus right here and replace it with a minus. All right, now we have the first part. Let's go ahead and do the rest of the quotient rule. The rest of the quotient rule is just f. So our top function, x squared cosine of x, minus times d low. So low, this is the lower function, low d high, so the derivative of f, minus high f d low, so derivative of g. Derivative of g is just cosine of x, so that's the derivative of sine, and the derivative of 1 is just 0. So we cancel that out. Over low. So it's just sine of x plus 1 squared, and that is all. Now, again, you don't need to simplify these. Usually this will be sufficient enough for your answer. Calculus doesn't care about algebra, it just cares about the calculus. So this right here is the answer for your quotient rule.